Hello learners, until now we have discussed about the science communication, different channel of communicating the science. Then we have discussed about the different research metrics. After that we have discussed about the different sources of extraction of data, like we have discussed about Scopus, then we have discussed about Web of Science and PubMed and how we can extract the data from these particular databases. After that we have also seen about the basics of R, how we can install the R and R Studio, and what are the different objects and different object types are. And after that we have also seen the three of the theoretical laws like Bradford law that helps in identifying the core sources. Then we have also seen the Lotka law, which tells about the scientific productivity of the authors. And then in the last we have also seen the Gibbs law, which is related to the frequency of words. So in this particular week we will be discussing about the descriptive analysis. Descriptive analysis helps in understanding the what given data is. Okay, so it summarizes the data set to identify the patterns and trends and relationship. So we get insights into what has been done without making prediction or prescribing any action. So in descriptive analytics we are not predicting anything, just we are explaining that this is the thing, this has been done. Okay, so frequency is the core component of descriptive analytics, and basically where we count the occurrence of a value in a data set. Frequency analysis gives the answer to question like how common are certain values, what is the distribution of values across the data set, are there any outliers of patterns that we need to know. Okay, so if we talk about in terms of research productivity or related to this course, frequency analysis can derive the answers like who are the top prolific authors in a like particular journal, or who are the prolific authors in particular country. Okay, so these kind of analysis can be done with the help of descriptive analytics. So in order to do the analysis on scientific productivity, we need to handle the two key parameters. Okay, so one key parameter is the publication and another is citation, and we need to do counting of these two parameters whenever we will be doing the assessment of research productivity. But during the counting we need to take care of few of the things. Okay, so the first and very important thing is the data source what we are using in. The selection of the data source is very critical, as there are different data sources are available like Scopus, Web of Science, PubMed, etc. And all these differ from each others in terms of coverage and scope. Okay, so next thing what we have to take care of is that type of document we are considering for the analysis. Okay, like we have already discussed about that there are different type of documents are published, like conference paper, book chapter, research article, review paper, notes, then data paper, editorial, etc. It is again important thing to note down what document types you will be considering for assessing the unit of a publication. And the last is related to citation. In citation we can have like self citation, local citation, global citation, or maybe the what kind of sources we have selected for receiving the citation. Okay, so let us understand all these points with some examples, then you will have more clarity on why I am saying that these points to be considered before the assessment of the research productivity. So say for example this is a scientist A and this is scientist B. Now scientist A has 8 publications, so 8 publication and 5 citations, and scientist B has, let's say, 10 publication and 3 citations. So in this kind of a situation we can easily say that the scientist B has more number of publication compared to the scientist A, and we can say that scientist B is more productive than scientist A. Okay, and based on this assessment we can easily assign the reward to scientist B. Okay, so now take the second example where we will see these publication in a deeper sense. Okay, so what exactly it is? So say for example we are looking for a particular kind of data source. Okay, so I am taking a Scopus as example. So now I am considering Scopus as a database for the analysis. Okay. So now we will say that out of 8 publication, scientist A has 5 publications in Scopus, but scientist B has only 3 publications in Scopus. Okay. If we see this scenario, that scientist A has 5 publications in Scopus and scientist B has 3 publications in Scopus. If we see only this scenario, forget about the earlier case. Okay. If we see only this through Scopus, then we will say that scientist A is more productive than scientist B. Okay. And now we will say that scientist A is the winner. Now take another example, that the kind of document type. So if we talk about in terms of number of documents, this scientist A has published 2 publications as research article, and this scientist B has published all 3 publications as research article. Now, if you are doing based on the analysis that you are considering the Scopus database, then if you are assessing only the research article, other documents, okay, like the ranking agency used to do, okay. So the ranking agency does not consider all kind of document types, okay. So if you are focusing on only on the research article, then here in this case, scientist A has 2 publication and scientist B has 3 publication as research article in Scopus. Now, in this case, scientist B will be the winner. So, in the first example, who was the winner? B was the winner. In the second example, who was the winner? A was the winner. Or in the third example, who is the winner? Again, B. So, this is why I am saying that it is very important that what kind of data source you are taking in, okay, and what kind of documents you are considering for the analysis of a research productivity of particular author or particular country or particular institution, okay. So similarly the case of citation can also be seen, like the author has 5 citations and this scientist B has 3 citations, okay. If I say that out of these 5 citations, scientist A has 1 citation from any international source and other 4 citations are from self. But now if I talk about scientist B, it has all 3 citations from international source, okay. So the concept of citations, self citation and like these global and locals are still in gray. So we cannot say that exactly this self citation is in black and other kind of citation is in the white, okay. So but it's always worth to consider these points whenever we count the publication and the citations. So once these points are considered, let us now start the descriptive analytics. So it includes measure of central tendency and measure of dispersion. We will see each one by analyzing the data manually, and then we'll see in the R, okay. And I'm doing the manual analysis of few of the concept of descriptive analytics to give you the more understanding about that particular concept and how you have to use the R for calculating those things, okay. So let's start the first thing. So let us consider that this is a data extracted from Scopus with only 3 variables: title of the paper, year published, and then number of citation it have received, okay. So this is the title, then year and cited by. And by default, each download in Scopus come with this extra column of a link. We will delete this and consider the only 3 for our analysis. So we will not consider this, and we will take care of only these 3 variables. So our data set is this. So the first thing is, what we used to do is count the number of publications, okay. So here what we will be doing, like we will count the number of publication year wise. So if we see here, like in this particular data set, number of unique values, so we have 2023, then we have 2022, then we have 2021, then we have 2019. Okay. Now we will count the number of publication in each year. So in 2023, the occurrence of 2023 is only 1. So this is 1. Then 2022, 1, 2, 3, 4, 5, 5. Then 2021, 1. And then 2019, 1. Okay. So this is our frequency of this particular data set. Now we can easily infer that for this particular kind of a data set, there are like 5 number of documents are there in the year 2022. So from here the result shows that in the year 2022 the author or the particular institution has the highest number of publications, that is 5. Okay. Now we will do the same thing in our. So if you notice here that this particular thing, what it's saying is that package dextol and moments required but are not installed. Okay. So if you use this script, I'll be sharing the particular script on the GitHub. So it will show, because if the package is not installed. Okay. So again, this is the beauty of R Studio, that it automatically pop up that this package is required, you install it. Okay. We'll see later in the part that where this package is required. Okay. We have already extracted the data. Now the very first thing what we will be doing is to import the data into RStudio. So here we will be importing the data. So to import the data, there is a function called read.csv, because our data set is in the CSV file. Okay. So Scopus provides the features of downloading the data in different formats. So I have downloaded this particular kind of data in CSV format. So I am running this function read.csv, but it has many other functions are also available for importing the other kind of data set. Okay. So whatever the kind of data set you have, you can import into R. So I am assuming that you have the read.csv. By default, many times we used to download CSV or Excel file from the data sources. So we will be using the read.csv function to import the data. So this is the read.csv and this is my data set. So what I'll do, I'll just run this command, and if I run this, my data is import. So after importing the data set, let us now see what exactly the data is. So if I see this data, okay. So this is the data set. We see here, if we see here, this is our data set. So we have imported this into RStudio and we have assigned this to a name, that is dat. Okay. You can assign the name whatever, like what I have discussed in the previous weeks. Okay. That it depends totally on you that what names you give. So I am giving the name dat. Again, an important thing you must note it down here is that I have just mentioned only the file name of my data set, because my current directory is in the documents. Okay. And where this data is available. Okay. If your data is available in another directory, then you must change either the directory first or you give the proper full path. Okay. So say for example, if your data is in the download directory, okay, so you have to give the path like this. Okay. So I have commented down. So this is my download directory and this is where my data is. Okay. But if you see my current directory is documents, and this file is also in the document directory. So this is where my file is. So that is why I have just given only the file name. If your data is in the download directory and if you haven't changed, then you have to give the proper path. And if you have changed your directory by using the function set working directory to downloads, then only you have to name the data. Okay. So as a good practice, it is always recommended that whenever you are starting the analysis or whenever you are importing the data, you must check what exactly your current directory is. Okay. After this, like our data is imported, and we have also seen that data is correctly imported. So here we can see that data is correctly imported. Now, as per our counting of the publications, what we were doing manually, we have counted that what were the unique values in the data set. So those were the years. So those year were 2023, 2022, 2021, 2019. Okay. So same thing we will do in here also. So our data is this, and it has 3 column. Okay. And we will access that particular column only. So we are not doing the analysis on title or the cited by. We are only counting the year wise that number of documents. So for that we will be considering that particular column. Here also we have considered this particular column year only. So I'll do here this. So unique year. If I run this, so it is saying that these are the 4 values which are unique: 2023, 2022, 2021, 2019, and that was we have seen in manual also. Okay. So for this calculating the unique values in the data set, we have used unique function. Now we will assign this value to a particular object. So we have assigned to this. So if we see the value of this, okay. So now the next thing after finding the unique values in a data set, so we need to know the occurrence of that particular value. Okay. So for that we will be using the function table. So what table does? Table just count that unique value and also count the frequency of those unique values. Okay. So if we run this, so now this table function has given this values that in 2019 there is only one publication, 2021 this is one, 2022 there are 5 publication, 2023 there is one publication. Okay. So what table is giving? A table is giving that there is a like 5 occurrence of 2022 and all the other 3 are only single occurrence. Okay. And then we, based on this analysis, we can infer that the 2022 was the most productive year for this particular data set. Okay. So if you have noticed here that the earlier output of this function was there is nowhere this var1 and frequency is there. Okay. So as soon as we do the data framing of this particular table, this column name is assigned. Okay. So I am assigning this to an object. Now if we see here that there are 2 columns name are there, var1 and frequency. These may create some like whenever we are doing the analysis may create some confusion. So for better we will be changing these column names. So if you remember, we have already discussed how to change the column names. So we'll change the column names like this. So I'm changing the column name of var1 to year and the to frequency. So if I run this, and now if I'll see the value of this, so now our one analysis is done, but we have done manually. Okay. So now we will see this data set. So this is our data set, and we will save it as to a external file. So like the way we have imported the data set, in the similar way we can export the data also. Okay. So to export the data, whatever we are working on and whatever our analysis is, we will be using the function called write.csv. Okay. And these function names are based on what task they are doing. Okay. So if you see the function name read.csv, it means that it's reading the data, it's not doing anything. But if you see the name of another function which we are using for exporting the data, it is write.csv. So it is writing the data set. So I am using this write.csv. This is my particular data set, and I am giving the name of that file. Okay. Write.csv. So this file is created. So again here also path matters. Okay. If your current directory is documents, it will saved in the current directory only in documents. But if your current directory is downloads or desktop, it will saved in desktop or downloads. Okay, so we'll see here documents, and if I just refresh, so frequency analysis is there. So one analysis is done. So now we have done the analysis first, and then we have also saved the analysis to our external file. Now we will move to the second part of cumulative frequency. Okay. So to calculate the cumulative frequency manually, what we used to do, so for our 2019, 2021, 2022, 2023. Okay. So this is our data set. In 2019, there is one publication. This is one. Here is 5, and again this is 1. Okay. So this is our frequency. Now cumulative frequency, what will be? Like this will be 1, then this will be 1 plus 1, and this will be 1 plus 5 plus 1, and this will be 5 plus 1 plus 1 plus 1. So this is 1, this is 2, this is 7, and this is 8. So now we will see in R that how we can calculate the cumulative frequency. So now we don't know in R how to calculate the cumulative frequency. Okay, how we will do that? We have already discussed in the week 4 that we will seek the help, and how we will seek the help? We will seek by using the fourth quadrant. So we'll go here, we'll write cumulative, and if I enter this, these many results have been came, and what I am looking for, I am looking for this cumulative sum. If I click here, so it is showing the example also here. These are the examples that how I have to calculate the cumulative sum. So if I use this function, so what exactly this argument is? So it generated the sequence of 10 values. So arithmetic progression with the common difference of 1. So if I do like this here, 1 is to 10, there are 10 values are there, and the cumulative sum of these 10 values are like this is 1, then this is 2 plus 1, then this is 3 plus 2 plus 1. This is how the cumulative sum is generated. So the same thing we will be doing on our data set. So our data set is this. So what we will be doing, we will be giving our data set, and then we will call this function. So now if I run this, so we have got our cumulative frequency. Okay. So now we will convert this to a data frame. So I have converted to a data frame. So this is my data frame. So this is a year, and this is a cumulative data frequency. So I'll run this, and our new data frame is created. Okay. Now if you see here that this column name is too big. Okay. And what exactly how this column name comes in? So this is saying that this is a cumulative sum of this particular data set. Okay. So that is why come sum dot that fq is there. Okay. So this is also a kind of a identifier that this particular column is related to a cumulative sum of the frequency. By default, the data frame takes the value whatever it is assigned. So that is why it takes this value as a column name. So now we will combine this cumulative frequency with our earlier analysis. So to do that, what we have to do, we have to create a data frame. We have already have one data frame which have year and this frequency. Now we will add the cumulative frequency. So how we will do that? So this we have already have, and we will add one more column from this particular data frame. So this is our data frame, and I have used dollar sign. So if I just remove this, and if I hit the tab, it will automatically come. Okay. So now if I run this, so my data frame is created. So this is my year, then the frequency, then the cumulative frequency. Okay. Now if you see this column name is too big, okay, like we have to make it shorter column name for because when we will be doing multiple analysis, this column name will be again and again dot dot, then again a different name, okay. So we'll change it to a simpler word, so that we can easily understand that what exactly it is. So to do that, we will be using the call names. So our call names are this, and we will give the this. So here is already their frequency, and we can use this cumulative frequency as a another column name. So if I do like this, so now if I see the value, okay. So this is my analysis is done, then frequency and then the cumulative frequency. So the two analysis is done, and similar way the way we have earlier saved the file, we can save this file also as using the write.csv function. So as a practice assignment, I request you all to save this file with your name and share with us in the discussion forum, okay. Now if you have noticed here that I have used this camel kind of writing for giving the column name. If you have seen this kind of example, that whenever a URL has any space in the names, automatically a percentage sign is generated, okay. So to avoid this kind of confusion, we generally don't use like space, extra space kind of thing in the names. Always it's a good practice that you don't give space in the column, okay. Now so there is another way of changing the column name, because if you have noticed here that you will say that the two columns are already there, okay. So why I am typing it again and again and I am writing this? So is there any option to change only that particular column name? So this is where we can change the column name of that particular column. So what we are doing here is that it's a complex kind of function. When we will be discussing about the function, you will get the more understanding about this. So I request you to try this function after the second lecture when I will be discussing about function. But I'll just give you the brief. What I am doing here is, so here I am calling the function call names and saying that this is the call name, and where this value is, call name is available, okay. And if you have remembered that this particular sign, what it will generate, it will generate false false false. Why it is generated false false false? Because there is no call names are available with this come some dot data fq, okay, because I have already changed here. So first I am checking whether there is any occurrence of column name is there, and then if any occurrence is there, then change that value to a new column name. So here in this case all these things are false, and after that wherever is true, it change the column name, okay. So this is an another way, I will say it's like an advanced way of changing the column name, and it requires the understanding of both the how the function works and then the logical value type we have already discussed. So I'll request you try this after the lecture of functions, okay. So now we will move to our another analysis. We will calculate the relative frequency. So how we calculate relative frequency manually? So what we used to do, first we calculate the sum of frequency. So sum is 8, and then we'll calculate the relative frequency of 2019 is 1 by the sum is 8. So it will be 0.125, okay. And similarly for this relative frequency it will be 0.125, and for this also 0.125, and for this is 5 by 8 is equal to 0.625, okay. So this is how we calculate the relative frequency. Now we will see how we can calculate the relative frequency in R. So so to calculate the relative frequency in R, what we will be doing, we will call this operation, and after this operation, all the values are will be retrieved based on these operations, okay. So if I do like this, if I run this, So if you notice here, that is our relative frequency. So I can assign like this. So now if I check the value of relative frequency, so this is my relative frequency. Okay. So until now, what we have done, we have calculated the simple frequency, then we have calculated the cumulative frequency, and then we have calculated the relative frequency. So this is our one analysis, and we want to as a one single data frame for this analysis. So what we will do, we will, this is our earlier data frame which have the frequency and the cumulative frequency. Okay, and I'll assign this relative frequency also with this. Okay, so now I'll assign this. So this is my relative frequency. So my final data is this. Okay. So this is my year, this is frequency, this is cumulative frequency, and this is relative frequency. Okay. So after that, we will export this result as an external file. So how we will do that? We will use the function write.csv, and that is our data frame, final data frame. Now I'll give the file, the location where I want, and I'm giving the file users. So I am just typing the first character, and I am putting the tab. So it's del, then where I want to downloads. If I run this, it's done. Now if I see here, there is no file. Okay, the final file is saved in downloads directory. There is no document directory because I here mentioned the this path. Okay, so if I have typed like this, now if I do like this, and if I go here, so this is my file is created. Okay, and my earlier file you can see in downloads. So in my download, this is the file. Okay, so this is how after computing the whole analysis, you can export the results to a different file. Okay, until now whatever we have discussed is we have discussed through a long way to understand that how things works. But when we have the understanding of what the particular concept is and how that functions work in R, we can easily do the analysis in just a fraction of seconds. Okay, and I'll show you the that way also. Okay, so what we have to do is we have to like first read the data. So I'm reading again, and now what I am doing, I am just tabling the year and then the cumulative sum. Okay, okay. So here we have to like do some modification also, like we have to delete some these columns, but in a shorter way, in like just two commands, we got the analysis of frequency and the cumulative frequency analysis. Okay, so this is how you can do this frequency and then cumulative frequency and this then relative frequency analysis in R. I have shared the one practice data set in on our GitHub repository. You give a try on that data set or for this analysis, and let us know in our discussion forum if you face any of the issue and if you are getting an incorrect value, if you are doing it manually or doing it in R. Okay. So I'll see you in the next lecture where I'll discuss about the functions, how we can create the function, and then the measure of central tendency. Thank you.